Hey, Valor. Are my only student today. Let's see what happens.
I'm pretty sure that Max and Sarah are at their chemistry class, which ends at 10, and they're coming.
They
Great.
don't normally have chemistry. It was just.
They don't normally have chemistry, my mom said, but
It was just today.
our co-op was having chemistry today from 9 to 10.
Okay.
So
Good.
I'm pretty sure they're still coming because I think their mom's a teacher, and I think they scheduled it around math.
Okay. Well, I'm glad it's just that and they're not having like internet issues or something or illness or something. Let's see. I think if I had finished writing everything I needed to write. Let's see. Maybe not. Let me write a couple more things and then I'll share my screen.
Good morning.
Morning.
How are y'all?
Oh, there you are. Okay. I didn't have my, I put the view thing down so I could write on my screen. So,
Hey, congratulations that you let the whole church know Sunday. I bet you had people go, hey, what is this?
I did in the prayer. I was like, what?
yeah, I didn't want the announcement. I'm like, I'm not doing that, not playing that game, but the prayers are good. So,
Well, great.
that is Miss Johnny.
Hey,
Good
Matthew.
morning, Matthew. You're being such a good boy.
You can come around here where she can see you, although that might be kind of hard because you're short.
What is he doing?
There.
Good morning. Look at that beautiful face. You're such a happy boy. Good morning to you.
The older you get, the more you look like a perfect combination of your granddad and your dad.
You do. That is true.
Yes.
But yeah, Dad is at work.
Dad is at work. But
You
you
still look
look
like
like him. Your face looks like Daddy's face.
But you have like this, I think you have like the facial structure of like your grandfather, your mom's dad.
I think so.
Granddad, is that what he calls him?
He calls him Grandpa. He calls both his grandpas Grandpa. So
Grandpa.
confusing. They're both
And your
Grandpa
face looks
David.
like Grandpa too.
Your face looks like both grandpa.
Yeah, the Getch genes are very strong. Yeah, Mom has met you.
Good to see you.
Okay.
Oh, you're singing it now.
Yes, we sing everything. Everything is a song.
Yeah.
Matthew, are you a fan of Winnie the Pooh?
You
You like Winnie the
Matthew?
Pooh?
You don't know that much about him. You've seen a little bit of like the old Winnie the Pooh cartoon that was around when I was little. He's seen a little bit of that, but he got distracted by something in the middle and went off and did something else. So
I think Ethan said that he loves Star Wars though.
Yes, Brooke gave him some Star Wars books when he turned 2. Like they're golden books. They're tiny little golden books, like with pictures of Star Wars and a little bit of a story. Not really. Bookies. So he loves those.
Hey.
Yes, the name of it, I'm a Hero. That's right. There's another one called I'm a Hero. And then the first
There
one
you
is I'm a
go.
Wookiee.
Wookiees.
They're great literature. Yes. You can read those today. I haven't read those in a while.
I love how his face just lights up.
He thinks it's quite funny.
I don't know how to read those.
You don't know how to read those? Well, I'll read them to you. You can look at the pictures. I'll read them to you.
I'm not smart enough yet.
He thinks he
Bye.
has other books that he reads that are like one word on a page. So he thinks he's reading those because he's memorized the words as he flips the pages. So that's why he's saying he doesn't know how to read the Star Wars books, but he thinks he does know how to read these other books. He reads them to me every day. So
There you go.
a good reader.
You are a good reader. And you're a good boy to mommy.
Baby, a bit my side can read and good.
Well, babies your size, babies a little bigger than your size can read. And they're not babies either. They're little boys your size and older can maybe read a little bit. Babies can't read.
You're almost there.
Very into babies right now. You know what babies can do and can't do.
I remember when Hudson saw Graham for the first time, that he looked at him and he said, "My baby," you know, and just like, okay, he's mine.
And then I came back here.
You run around the room and then you came back here?
Yeah.
Yes.
Oh,
He narrates
I get-
everything.
he does what?
He narrates everything. He's either singing or narrating.
That's lovely, though.
I think so. Bless you. What do you say? You say, excuse me. Good job. You finished with your Cheerios? Nope. He's eating- That's always his snack.
Back
while
to the
I'm
Cheerios.
eating is Cheerios. Because they're clean and he doesn't have to be at the table and it's easy.
Yeah, they're a great thing. Whoever invented
They
them,
are.
they really help moms.
Yes, they do.
All right, well, I'll let y'all get back to math.
Good to see you.
Good to see you.
Okay, I am recording here. That'll be a fun part of the recording if anybody watches that later. Let's see. Let me share the screen. 'Cause I was in the middle of about to talk about this week, I guess, is our last week of class before Thanksgiving. So Sarah had been asking about the test last week, and I'm still nowhere near talking about the test, but I did want to talk about this week. Finish 6.6 and 6.7. That is the end of factoring. So before Thanksgiving, I would like, before we go and just completely clear our minds for a few days, I'd like us to be done with factoring. And then when we come back, Thanksgiving, that is a long word. There's only 2 things left to do before we take a test, but it's not something we're going to finish in like a day, maybe even not finish in a week. 6.8 is how you put, when you put factoring into practice, using factoring specifically in applications or word problems, we'd probably call them. So that's why, that's one reason we don't want to rush. It's not going to be like we come back after Thanksgiving, have like one class, and then you're taking the test the next day. So 6.8 is going to put into practice everything you've learned about factoring in chapter 6. And then also, they don't give it a number, but I'm really a big fan of treating this as its own section. So let me write down exactly what they call this. They call it the integrated review, and we do a test review anyway. But this chapter, it's worthy of having maybe a couple of review days. Integrated review is all about mixing it up, throwing a bunch of problems at us that involve factoring and just having us see if we can get through them. So I'm not sure the order that we'll do those 2 sections after Thanksgiving. I kind of feel like the integrated review section will probably come first. So the order that I wrote those is probably going to end up being wrong. It's perfect because they have this review section and we're going to be getting to it right after a holiday break. So I think for multiple reasons, this will be a really good thing for us. And then the test itself, again, no word on, I'm not even close to writing the test. I might write it over Thanksgiving if I get really motivated, will be 2 parts. As I kind of off the top of my head said last week when Sarah was asking that question, there will be an open book part.
I didn't track for.
Okay, go watch for him, see if he comes. And then there will be a closed book like the regular part. Okay, well, I'm sure he'll come here. The open book part will be, and I'm going to just take the time, since Max and Sarah aren't here yet, I'm going to take the time to just put the sections that will crop up in both of these. 6.1 and 6.2. That was like exponent rules. I don't see any need to even test on 6.3. And 6.4. But I want to make a note here. 6.1 and 6.2 kept talking about scientific notation. I don't want to test you guys on that. That's just kind of a footnote to what we're doing, and it's super important, but not so much in this class, more in science classes. Okay, so the open book part of the test will be from these 3 sections, and I skipped 6.3 again on purpose. And then the closed book part, let me try to be clearer here. The closed book part will be factoring. Anything that involves factoring. So from what I am remembering, that's 6.5, that's 6.6 where we are now, 6.7 where we'll end this week, and then 6.8 because it does use factoring. We're solving problems by that point, but we use factoring. So roughly divides the chapter in half, but it does not divide the amount of problems in half. There's probably fewer and shorter problems in the open book section. Closed book, the factoring, the more important part, problems are a little bit longer. So I'll try to balance that and make sure that one half of the test doesn't end up gigantic and the other half doesn't end up tiny. So that's where we're headed. Basically this week, finish off the factoring, and then coming up after Thanksgiving, start using that factoring in word problems. Always an unfortunate way to end a chapter when you have to end it with word problems. What I wanted to do today to start off, since we were just delving into all the options that exist in this new 6.6 type of factoring at the end of class, I wanted to make note of 3 things. And I'm just going to say discuss because we won't actually work all 3 of these. 19, 49, 51. I think we'll work 2 of them. I wanted to, let me make sure. I took a bunch of notes, but I didn't actually work out the homework. So let me make sure. Yeah. 19, I think I had warned you guys when I sent out the homework there. One of these problems will be non-factorable. 19 is it. So I think, well, it shouldn't take too long. I'll go ahead and do this. Let's look at why this particular polynomial ends up not factorable. It's a rare but wonderful thing when that happens. So I'm going to keep asking overall GCF, no, except 1. Today is the day we finally get to some overall GCFs. So after weeks of writing that and really not getting anything out of it, we're going to get somewhere today. Okay, so the new method that we learned is to take the very first number times the very last number. I'll tell you after I teach. When we read that book, we can read that book before your nap. I'll tell you about that person. He has, speaking of those Star Wars books, he has brought one of the Star Wars books out and wants to know why one of the characters is bad. So that'll be interesting. So you take the first number times the last number. Sometimes they're called A and C. And the middle one is called B. You multiply them, that's an attempt at the multiplication dot. And whatever you get, you're going to have to factor it. You're going to have to break it down. And I usually start at 1. So this would be 1 times negative 40. But when you have a negative number, it's worth noting that this could also be negative 1 times 40. A negative number can be arrived at 2 different ways. And our end goal for this stage of the problem is to find the pair of factors of negative 40 that add to be positive 25. So these two numbers have to do double duty. They have to multiply to be negative 40, and then they have to add to be positive 25. And because 25 is a positive number, not a negative number, I'm just gonna, this is 25 is positive. That's going to completely guide which one of these lists of factors we pay attention to. I'll write one more set of 2 times negative 20 or negative 2 times 20. Okay, maybe afterwards when I'm not teaching, okay? Yeah, keep it around. So if I add 1 and negative 40, I get negative 39. If I add 2 and negative 20, I get negative 18. Basically anything on this list, the negative number is the bigger of the two. So adding a really big negative to a really small positive is going to always give me a negative. So that list, nothing on that list can ever add together to give me a positive anything. So I'm going to disregard it and continue on. Here, 3 or negative 3 will not go into 40, so I skip it. Negative 4 will. Negative 5 will as well. 6 will not, 7 will not, 8 will, but remember by the time you get to those really essentially twin pairs of factors, they just go in the opposite direction, you know you're done. You don't have to continue listing factors. You're completely finished because everything past that point is just going to repeat what you already have. So we have all our factors. We can't, if we're just dealing with 2 numbers, because you could invent ways of getting 40 out of like 3 numbers or 4 numbers, but we just want pairs. If we add each and every one of those pairs, there is not going to be any of them that add to be positive 25. So over here, none of those pairs of factors add to be positive 25, or for what it's worth, any kind of 25, negative or positive. So when that happens, it's always a good idea just to check our work, just to go back and make sure we did all of this correctly. But I just checked the back of the book, so I know where this is heading. Since none of these work and we've done everything correct, the polynomial, the whole polynomial, okay, Matthew, you're gonna have to take yourself, okay? The whole polynomial is not factorable. And what the book will say, if you check your answer in the back, they'll literally call it prime. It's like a prime number that's not divisible by anything besides itself and 1. This is a prime polynomial. Nothing can be divided out of it. So I wanted to go into a little more detail because all I did when I assigned the homework was just let you guys know, hey, there's one of your homework problems that won't be factorable, just so that you didn't beat your head against a wall when you came across that problem and think that you had done something wrong. Because every once in a blue moon, and I'll try to be nice and remember to put one of these on the test, because it's nice to have a breather. It's nice to have one where maybe you don't have to do quite as much work, maybe. If you're like me, you'll end up doing as much work anyway, because you'll rework this like 7 times, freaking out about why it's not factoring. So, but in theory, I want to put one on the test that is not really able to be completed. Okay, and then number 49 and 51, there's nothing really magical about these. I just want to, because we had not gotten to view just the range of problems that exist. Okay, so here I'm in descending order. Everything's good to go. I need to jump to the place where I take my first number and my last number times -2 and get -6. And -6 is the number I'm going to be factoring. Now, let me just throw this out here. I was going to, divide and conquer and have various parts of the class doing various things, but right now it's just you and me. So I won't make you like work it from start to finish, but can you take a moment or two and figure out what are the correct 2 factors of -6 that would add to give me a -5? That's what I'm after, is a -5 here in the middle.
Ma'am, do you think the answer would be like 3x plus 1 in parentheses, and then the other set of parentheses would be I think x minus 2?
Yeah, absolutely. So you got not only the factors, you got all the way, which is great. Yeah, that's it. I had worked it off to the side. So in the notes, we'll just complete this off. So if I have 1 times -5, no, I don't. I'm thinking a step ahead, and that's never good. Or I have -1 and +6. Not only can we eliminate the second list pretty quickly because it adds to be positives, but when we turn our attention to the first list, we are good to go right there. So 1 minus 6 equals -5. That's great. Okay, so the rewrite step where we expand, we leave first term alone, we leave last term alone. And then I'm going to put plus 1x minus 6x. It's always tempting to skip this when someone gets the problem right, but I want you guys to be able to reference this, as you study for the test. So 3x plus 1, pull out the negative 3x plus 1. There's our GCF. And then And sure enough. Yeah, and just what you'd gotten. So perfect. Okay, now 49 and 51 I picked for class today because of the positioning of the negatives. But when it comes to like comparing the difficulty levels, 49 is fairly average. And then 51, just the size of the numbers involved. So this will be our last little review problem. We'll just jump right in here. I haven't worked this one out. I started on my paper here. Okay, what is Matthew saying to me? Okay. Whoops, what am I doing? There we go. So what color had I been using? I completely lost my mind there for a minute. Okay, I've been using blue. So there's, oh no, overall GCF. Okay, no overall GCF. I'll just write that. And then the blue part. So the 8 times the 15, thankfully they're positive, but that doesn't really impress me too much because the number that they come out with is really big. So I've got 120 that I have to factor. And 120, yes, it's 1 times 120. Yes, it's 2 times 60. Yes, it's 3 times 40. But it's also -1 times -120 and so on. And because we're trying to add to get -26, we can throw away this list with all these positive numbers. That won't get us anywhere. Okay, so off the negative list, can you find the right 2 factors? Or if you've done this problem or you feel confident about it, feel free to go all the way like last time. Can you find the right 2 factors there?
Would the two factors be 4x and 2x?
4x and 2x are, they're in the final part of the problem. Like it's going to be 4x something, 2x something. Is that kind of what you were thinking, where the like the 4x and
Yes, ma'am.
yeah, they will go there. Now we just need to figure out, what's here, what's here. So from the list that was going towards making 120, I had stopped at, -3 and -40. If I keep going, -4 and -30, -5 and -24. Yeah, it is 24. I have that on my paper. And I'm kind of pausing on each one and adding them together. So -4 and -30, that's -34 if I add them. -5 and -24, -29. I'm getting closer to -26, and that's a good sign. So if the next pair of factors don't do it, that means it's probably not factorable. So -6 times -20, they give me a -26. So I can stop this part of the process. And if I'm adding them, that's what I was trying to match, that middle number right there. And then before we figure out what goes where I had my question marks, I'm going to rewrite the 8x squared plus 15. And then in the middle, I'll just expand it out. So -6 and -20 are the two numbers that expand out my middle term. And then if I divide the problem in half by a factor by grouping, it looks like a 2x can come out from the first couple of terms.
What's the princess pile of the day?
Yes. I think so. He probably will. What's going on? His music keeps turning on. And then if I pull out a -5.
And this is like, yes, I know that.
No, my timer hasn't gone off yet. So it looks like 4x minus 3 and 2x minus 5. Those are the, so -3 and -5 are the two numbers that complete the problem. So yeah, the 4x and the 2x start the problem, and then we need those two negatives at the end to complete it. I'll play with the cord, Matthew, when we gotta go play for a little bit longer until my timer goes off. Okay, so that was what I wanted to look at from the homework. Just to set us up with what we had learned last time. All we have to do for the rest of class today is just clean up a few lingering things. And the main one, or I'll say the main two, there's like 4 things we need to look at. 2 of them are important, 2 of them are less important. And the first one is a nice shortcut when what they call the lead coefficient is just a 1. So all the way back to the beginning, the book teaches this first, and there's nothing wrong with that because it really is the easiest part of the whole section. But if you learn it first, it gets harder to learn what we just did. It's easier to deal with what we just did if we handle it first like we did last class. So now we're going to backtrack a little bit. And here's what I mean by the lead coefficient. This polynomial is in descending order. And that means the lead term is in front with the x squared. And this is the lead coefficient. This 1, that's what they're calling the lead coefficient. So if I am being consistent to my method, the method that sometimes I said to you guys is called the A times C method, because this is called A and this is called C. If I just go with that method, like we've been doing, I take 1 times my 6, and because everything's positive in the entire problem, I don't even have to worry about making a second list over here. I just factor all my positives out, very quickly find the right pair of terms. 2 plus 3, that's 5. That's what I was trying to get here. And again, I'm just being very, very faithful to the method that we've been practicing, even though there's a shortcut that we'll discuss in a minute. Okay, so expanding my 5x so that it's 2x plus 3x. And x plus 2. Here at the end, what we end up with, notice that that 2 and that 3 are the same 2 and 3 that we had up earlier in the problem. And the reason is when we took our 1 times our 6, we might as well have just taken the 6 and factored it. So we did this extra step here. 1 times 6 is 6, and then we factored the 6. You can really just factor the last term there. You can really just factor what they call C, and you'll get the answer, because having a lead coefficient of 1 means you don't actually need this whole process. So what we can do, we can skip factor by grouping. We can skip the whole 4-term thing. When that lead coefficient is 1. In fact, this is how a lot of us learn to factor, like in basic algebra, is just essentially, if I can grab another problem here, this is practice 2, page 329. Minus 11x plus 24, just take the 24. That's going to be what you deal with factoring. And there does get to be a little bit of a complication if you have a negative, because you can form that 24 by multiplying a couple of positives, or you can form that 24 by multiplying a couple of negatives. And in fact, because we're trying to end up with a negative 11, we do have to stick with the pairs of negatives. And it looks like negative 3 times negative 8 are what we need. And so what we do here, we don't even have to go through that step of factor by grouping. You're just going to come down here, put your parentheses in, and then whatever numbers you found, negative 3 and negative 8, you just place them there in the parentheses and you're done. Everything is a lot more clear cut because you didn't have anything besides a 1 here muddying up the waters. You're basically just factoring C in such a way that the factors add together to give you B. And that's it. So this type of factoring, I know for a fact, I learned it first. And other books that I've seen teach it first as well, because it's so nice. You just deal with this number that you can very clearly see with your own eyes, factor it out, jump straight to the parentheses, and you're done. Unfortunately for us in this type of algebra 2, you won't see those every single time. You're more likely to see something with a 3 or a 5 sitting out front like we've been doing. Okay, so that's the shortcut if you have a lead coefficient of 1. Another thing we need to look at is what happens if you have one of those dreaded overall GCFs that I keep hinting at, but that we've never really had to encounter. We've had some problems where there was an overall GCF, but if we factored it out, we were finished. There was nothing else we could do. On the other hand, if we look at this practice problem, for example, we notice right away it looks a little weird because the highest power of x is actually a 3, and we're used to the highest power of x being a 2. Hey, Matthew. Got tears. I'm back, sorry about that. Okay, so in this problem, and this is one of the clues, if you have a polynomial that looks kind of funky, that can be a clue that there is an overall GCF hiding in there. So I'm going to give away that part and say, yes, there is. Do you have any idea, can you figure out what the overall GCF would be? What comes out, what divides out of all 3 terms? It's going to have a number part and it's going to have x to a power.
Just 3x.
3x, yeah, absolutely. So 3x is going to divide out. And when it does, I will still have 3 terms in my set of parentheses here representing the leftovers. So I'll have x squared minus 3x minus 10. And then good time to pause and just redistribute either mentally or just on your paper off to the side. Because you definitely, as simple as the step is, we definitely want to get it right because everything else kind of hinges on that. Okay, after we've pulled out our overall GCF, we always try to factor what's left inside. And back earlier in like 6.5, I guess, we would not have been able to. They would have stopped us, they would have given us a problem that was all focused on identifying and dividing out 3x. But now what's going to happen is we have a pretty good chance of being able to factor that polynomial inside. Now, I don't know why I wrote the 3x. I was knowing where the problem is going. I was trying to jump to the end there. Okay, now they're being really kind to us here in this problem because what's left behind is a problem that has a lead coefficient of 1. So for the note's sake, lead coefficient of 1. So we can use the shortcut that I just discussed. So this is why I didn't do a ton of problems with that shortcut, because the shortcut ends up being built into what we do for some of these extra factoring problems. Okay, so the shortcut is basically going to say, we can jump right to this stage. We know that there needs to be an x and an x because we're factoring x squared. And then we can just break down and factor -10. Now, yes, technically -10 can be factored a couple of different ways. Oops. We can say 1 times -10 or -1 times 10. We can say 2 times -5 or -2 times 5, but we don't really want to add anything together that will give us a positive, since we're trying to get that -3. So it looks like 2 minus 5 would give us -3. So that's what's going to drop down here, a +2 and a -5. Okay, so it's easy at this point to get carried away and kind of square off, box off our answer and say we're done. Really easy to forget that 3x. So sometimes I will just sort of like drop an arrow down just so I don't forget that 3x, that overall GCF, that's still there and it still has to be part of our answer. So especially if what's left in the parentheses initially was super complicated and we're having to do a lot of work off to the side, it's really easy to forget the 3x was there at the beginning and it better be there at the end or the problem isn't fully factored. So nothing really horrible about overall GCFs. It's just, I would say that's the worst part, is just maybe forgetting that they were there and going on about your business. So let's see. Yeah, I think practice 4 is worth looking at too. Okay, so 2b squared minus 18b minus 22. Now here, maybe a little bit less obvious that there's something fishy, there's something hiding in this problem, because we do start with the correct power of b. We have b to the second power. That's exactly what we would want to have. But what do you think? Can you see a number hiding in there that's common to all three terms? Okay, anyway, is there a number that you can find that divides into all three of these terms?
2.
Yeah, 2. So in one sense, that's an easier GCF than we had in the last problem. But in another sense, it's harder to remember that you have to look for it because you had no clue off the powers of the variable that something was hiding in there. Now, I will say, if you do not find the overall GCF at the beginning, it's possible to complete the problem. It's just that what you get in the parentheses at the end, there would be still a GCF hiding in there that in order to get the problem 100% right, you'd have to pull it out. You've got to pull it out at one point or the other. And it's just easier to force ourselves to do it at the beginning rather than the end. But if you miss it at the beginning, it doesn't mean the problem is completely unsolvable to you. Okay, so here's what we're left with. And because I see that lead coefficient of 1, not a lot of extra excitement needed. I can jump right to this stage. And then with the negative 11 there that I'm trying to factor, the more of these you do, the quicker it will become for you to find the right pair of factors. And in this case, though, they're kind of messing with our minds, because 11 is a prime number. So neither one of those work. So I'm going to say this. And they have flashed back to the time when all we had to do was pull out a GCF. So just to remind us, I guess, that those problems are still fair game. So let me box this in, and then in the notes, we're just going to write that interior, that leftover polynomial is not factorable. So what the book would say is that polynomial in the parentheses is prime. Okay, so we weren't able to get anywhere with the remainder of the factoring. That's okay. Again, just a problem that takes a little bit less time than 6.6 problems tend to take. Let me find a couple with a harder GCF. And again, I have not worked these, so who knows what this is going to turn out to be. This is page 332. We're jumping ahead, skipping some stuff we've already done, skipping some stuff that I don't want to talk about quite yet until we get the important stuff out of the way. Okay, this is tricky. There is definitely an overall GCF. See if you can figure out what it's going to be.
Three B.
Very close. You can actually take not only the 3 and the B, But since this is the smallest power, you can actually take b squared. You can come with an extra b. So hopefully that's knocked it down to a much more acceptable level. So that was 1, 9, 10. Okay. Yeah, and then what's left in there, that's what we're going to try to factor. No guarantees, but I did get the first couple of steps on my paper just so I can see where we were headed. So we're going to try to factor this. There is no shortcut here because the lead coefficient of the black polynomial here is 6. So what I'm going to do is rewrite that and attempt to not forget my 3b squared. So just a note off to the side, give myself plenty of room. Don't forget, sorry. Because this is definitely a harder problem and I'm very prone to forgetting that GCF. Okay, so what happens here, according to what we started out today doing, we take our first and our last numbers, we multiply them, and we start factoring the result. And I very quickly see that these pairs of positive numbers are not going to add to give me my negative 19. So what I'm really looking for apparently is this list. -1 times -60, -2 times -30, -3 and -20, -4 and -15. Yeah, that is it. Okay, so this is what I'm trying to add to get. My first list was a dud, but my second list will get me there. Okay, now because the lead coefficient here was a 6 and not a 1, that means my nice little shortcut is not open to me, and I'm just going to turn this all the way into a factor by grouping, a 4-term polynomial. I'm going to expand that negative 19b. There is a way we can avoid expanding. If it's starting to feel tedious, I will cover that at the end of class, but I'd rather we kind of pick up on the pattern here, and then I can show people a shortcut if they want. Okay, so out comes a 2b, out comes a -5. I realized earlier I had moved away from the order. What I was trying to do in class was always write my little tiny GCFs in the middle of the problem first, and then those empty parentheses for us to fill in. And I reverted back to doing it. There's the way I do it personally, and then there's the way I do it when I'm teaching, and those are two different things. So let me go back to the clearer teacher way. Okay, and seeing that I'm about to run out of screen here, just remind myself, bring down that GCF. So the overall finished problem, this is where the bulk of the work went in, finding out this 3b minus 2 times 2b minus 5, but of equal importance to get the correct answer, there was also my overall GCF. So the very first thing that I was able to pull out. Okay, now that concludes this is the end of the material for a 6.6 quiz. And I'm thinking, since Max and Sarah weren't in the live class, I'm not really comfortable assigning you guys a quiz since they're going to have to watch the recording, and that's automatically going to put them kind of behind where we are. So there will be a 6.6 quiz. It won't be today, but what I've just covered there, pulling out an overall GCF and then dealing with the rest, that's the end of what I would quiz you on. The rest of this is just, okay, What happens in this case? What happens in that case? And let me see, I think there were, yeah, there's like 3 problems here. This is, just gonna say extra stuff. Okay, so there's 3 practice problems. And they're just special. They don't fall within the scope of ordinary 6.6. And ordinary 6.6 is challenging enough. The first type is the kind where you have X's and Y's. For the first time in a factoring problem, you have X's and Y's, but no overall GCF. So it's not like you can just pull something out, divide something out, and get back to a normal problem. And this problem is really essentially a bit of a setup for what's going to happen in 6.7. So they're giving us a little bit of a preview of some 6.7 stuff. Maybe that's good, maybe that's bad. But if we see something like this, because there aren't a lot of options for us at this stage, we only have the possibility of pulling out an overall GCF. If that door slams, this is our second and pretty much final choice. So if you notice that 25x squared is what they call a perfect square. I kind of don't appreciate them doing this right now. What that means is it is 5x times 5x. It's the same thing twice. Yeah, 5x to the second power, or 5x times 5x. That's what a perfect square is. Same thing here. 4y squared is also a perfect square. And this relates to the idea of like square roots and stuff that we haven't talked about, but you might have found in other classes. So it's it's an expression times itself, 2y times 2y. When you see that, when you see a trinomial here, a 3-term polynomial that's led off by a perfect square at the beginning and it finishes with a perfect square at the end. Okay, so in this case, we always try the following. It's like we completely shortcut our normal methods. So you can call this you can add it to the list of shortcuts. Try it as that first perfect square plus that second perfect square. And of course, because it ends up being the same thing. That's a really, for where we are in this class, that's a really kind of a rare thing. And I don't think on the homework today I'll put any of that because we have plenty of that type of stuff in 6.7. But just to know, give you a heads up, what do we try when we have 2 different letters mixed into the same problem? So extra stuff, that was one of the extra things. Let me take that line away because this is still under the heading of extra stuff. Practice 11 on page 334. This is something that at first glance just looks like off the charts. Like how does this relate to anything that we've done? Okay. This is going to be So the first one was what happens when you've got X's and Y's. The second one is, for the first time, I think, in this algebra class, we are running into something that's called substitution. And that's where you see a more complicated little algebraic phrase, and you can replace it or substitute it with a letter. Notice that, and my clue here is that I have this little quantity x plus 1 that keeps being repeated, and it's grouped in a set of parentheses, which is telling me to treat it like a single number. What I'm going to do is a little bit of renaming. Anytime I see an x plus 1, I'm going to rename it as a letter of the alphabet. And just from long experience with the way these textbooks work, I choose U all the time, because later on in math, U becomes the letter of substitution on up into calculus. So it's nice when algebra books start out with U. Yours doesn't. Yours picks any old letter of the alphabet and sometimes gets confusing. So I'm going to put any letter works. A, Y, P, Q, doesn't matter. And notice what will happen if I rename the quantity x plus 1 with a letter. So I'll still have 3. But this time I'm going to have that letter squared. I'm still going to have my -7, but it's times that letter. And then I'm going to have my -20. So this is what I can try to factor, because it's much easier to handle something that looks like that than it is to handle something that's got these x plus 1s squared inside of it. Okay, now, if I were to factor that, according to what we've been doing, just consistency here, I would take my 3 times my -20. I would get a -60, and because it's a negative number, just given the configuration of the problem, for starters, I'd have 2 lists. But because I'm trying to add back to get a -7, I would have to eliminate this list over here pretty quickly, because only the list where the bigger numbers are negative will actually give me the negative that I need. Okay, so 2 and -30. If you're feeling really confident, you want to just dive into the middle of that list and try to guess or get to your 2 factors quicker, that's great. 15, 30, 40, okay, 60, yeah, that's right. 5 and -12, there we go. Okay, and just as a check, if I add them, there's that middle number. And so I can rewrite my polynomial, and it's got the u's in it at this point, that's okay. I've got my 3u squared minus my 20. Just like I did a minute ago, I just expand the middle like that. Check really quick to make sure it adds back to being -7. And just continue with the problem. At this point, the fact that there are u's shouldn't change what we're doing one bit. So the factored form of the polynomial at this point is like this, but I have to remember that U was, basically it's something that I inflicted on the problem. There were no U's in the beginning of the problem. So I may not see U's, I may not write U's at the end of the problem and get it fully correct. I'd get, you know, at least half credit there. So I want to replace the U's. I just put them in while I was doing math, while I was doing algebra specifically. So I want to take my U's out and very carefully put back 3x plus 1s. Okay, now when I do this, because the x plus 1s have to be protected, and I'm going to put them in a parenthesis right now just to emphasize that. They have to be protected. So I'm going to have like 3 times x plus 1 plus 5, for example, instead of 3u plus 5. And I'm going to go back to that habit we have of using brackets anytime we're in danger of confusing ourselves with too many parentheses flying around. X plus 1 minus 4. That's what the replacing step looks like. And then I really just have to keep going because algebra requires me, anytime I see something like this, it requires me to use the distributive property. You can probably already see that x plus 1 minus 4 is going to shrink like that. I'm losing the need for brackets now. I can go back, if you want, to regular old parentheses. And that's the final answer. So a problem like that is extremely dicey on so many levels. You have to factor correctly, you have to substitute correctly, you have to remember both to substitute and unsubstitute. I'm going to briefly write up just a guide for how you would substitute in this problem, because there's one more quick thing we need to look at, and it will be quick, I promise, because it's not my favorite thing in the world for algebra students to get taught. Okay. So we've got this. There's no overall GCF. So there's nothing we can do about the x to the 4th. But the way that we've been taught, we have these trinomials and they always start with x squared. So what we're going to do is substitute. And I am still opting for that letter U, just for personal preference. Watch what happens if I pick U to be x squared. So I still have my 6, I still have my -11, and I still have my -10. X squared right here in the middle, that's now replaced with U. And then x to the 4th, notice that x to the 4th, if we sort of rewind and unpack it a little bit, x to the 4th is the same thing as x squared squared. That's why this problem is going to work, because you have an x squared here in the middle, and then you have that quantity squared itself out front. So it enables you to do like that. And then factor. Okay. That's a couple of ways you can get clever and kind of force a problem to work out in these factoring methods that we're used to. Doesn't happen too often. I don't want it to happen too much like on a test or anything, but it's good to know how to do it. It's good to have that in your back pocket because those type of things do come out of the woodwork every now and again. The last thing I want to look at, and the book put this like front and center in this section. This is an optional alternative factoring method. What we've been doing today and last week is very consistent. We see a 3-term polynomial, we pull out any overall GCFs, and then the method that we go at from that point is usually to try and turn it into a 4-term polynomial so that we can harken back to 6.5 and do our factor by grouping. This method, and let me see if the book actually calls it what I call it. There's a couple of different names that it's got. Man, they take both names that I know and combine them. The guess and check method, also known as the trial and error method, also known as the trial and check method in your book. This is something that I feel like only benefits you if your brain works a certain way that mine does not work, or if you have taken so many math classes that you are just dead tired of the method that we've been using. The method that we've been using is very algorithmic, meaning it's a process that you can repeat and every single problem works through the same steps with no deviation. Those are always the steps that you use. Guess and check is for when you're just feeling impatient and you feel like you can kind of get to the right answer easier and quicker. Like your polynomial looks simple, or you're just so experienced at this, or you're just like a super brave person and you just want to go for it, is basically it. It's messy because, again, you're guessing at the right answer and then you're checking real quick to see if you did it right. So what you do, instead of like going to 2 times 6 is 12 and factoring that off the side, you just go for it. You recognize the fact that 2x squared, yeah, we're going to eat lunch in a minute. 2x squared can really only factor one way, thankfully. That's one of the benefits of an easier polynomial. You can dive into this method and eliminate half the problem. You know that 2 is only 2 times 1, or 1 times 2, same two numbers. X squared is only x times x. Those are your only options. So right off the bat, you jump into the problem, throw those two things in, and you're done with half of it. You only have to figure out, let's hang in there, only a few more minutes, babe. Okay, now 6. 6 is a bit more problematic because it's 1 and 6. Is it 2 and 3? And because we are treating the 6 independently from the way we treated the 2, we're not combining them into a 12. So we're not going 2 times 6 is 12 and working with them together. Because we're keeping them separate, it's not as easy to tell which of these pairs is correct. So what you can do is let's just take this one first. +1 plus 6. Just throw it in there, just go for it. And the way that we see if we're right or not is the checking part. Imagine if you were to FOIL distribute everything out, would you get 2x squared plus 13x plus 6? And specifically, we want to focus on the 13. Like, would we get that 13x? And if you were doing the FOIL method, first, outer, inner, last, basically, when you multiply these two terms, 2x plus 6, or 2x times 6, that's 12x, and 1 times x, that's what you would get, and then you'd have to add them together to make sure they made 13. And as luck would have it, and I really do mean luck because I had no clue where I was going, this checks out. You did something wrong? Oh, here, can you go get me a clean shirt? You're fine. Here. Let me take your shirt off and you go get me a clean shirt. I know. occasionally happens. I would say it happens to all of us, but I don't think that's okay. So I got there very quickly, and I'm kind of miffed about that because I really needed this to take a little bit longer. Let me do practice 6. Some of this I have done under other methods. Some of these problems I'm looking at, so I'm just rehashing some of the same stuff, different method. Okay, now here, if we're going to jump right to this stage, we actually have more options. Let me, before being what it is, so this problem is better for demonstrating the fact that this method is not always quick. So 4x squared can be either the more obvious 4x times 1x, or it can be the less obvious 2x times 2x. So that's a problem. And let me take those lines out of here actually because of what I'm going to have to do next. Then we've got our, what color did I use? Not that the color matters. Oh, I used blue. Just to be consistent. Then we've got our -6. So it is either 1 and -6 or -1 and 6. That's still a thing. That's still a problem. 2 and -3 or -2 and 3. So what I have to do, for example, I have to try out like 1 and -6 here. See what happens to me. Can I get that middle term? Well, here, when I multiply the outers, I get a -24x. When I multiply the inners, I get a 1x. That adds to be -23x. So that's not going to work. But the problem here is that I can't just, okay, I'll come help you in a minute. Just do the best you can, okay? I don't know that 1 and -6 are actually bad. I have to switch the order. I have to try -6 and +1 before I can officially throw them out. So this is a little bit misleading because when I'm doing this myself, I tend to erase everything you just saw me do. But for the sake of the notes, I don't want to do that. What I have to try, same pair of factors in reverse order. So it just, when you're trying to be thorough about it for teaching purposes, it's just a pain, honestly. What I was trying to get was 5x. It just, so that means I've eliminated 1 and -6, but I've only eliminated them from this case where I had 4x and x. I haven't eliminated them from this case where I have 2x and 2x. So it can be a long process. And I want to see if I can get, I wanted to see if I could get the right answer here. This is one where I know if I mess with it long enough, 3, if I did 3 and 2, 3 and 2, that could be 12 and 2. What if I did 2 and 3? It would be 8 and 3. Oh, +8, -3. Yeah, I think this is it. Okay, so 4x minus 3, x plus 2. I think that's what it ends up being because that is +8 minus 3 minus 6. This ends up, after a lot of trial and error, this ends up being the right answer. So if I had stuck with my 4x and my 1x and just kept going down the list, this ends up being the right answer. But this process, it can be long. And that depends on the problem. It depends on your level of experience. It just depends on a lot of stuff. There's times now where I will look at a polynomial and think there is no way I'm going to trial and error this. And I always revert back to what we were doing, the AC method, so-called. So I wanted to make you guys aware of that, but just know this alternative method, it's good for really simple problems, or in a later math class. It's not good for teaching people to factor, because it relies on, if you're going to get through it efficiently, it relies on a little bit of instinct that you have to build up with time. So I wanted to show it to you because there are people that jump on that and they like it. If you're one of those, feel free to. It really doesn't bother me what factoring method people use, as long as they can, you know, get to the factored form. Okay, the homework, I did not decide on because I wanted to see how far we got. So I will send the homework with the notes. And again, no quiz assigned today because of Max and Sarah not being here. And then the recording, from what I was trying last week, the recording should be up on YouTube soon. Go on YouTube. And of course, I'm still streamlining that process. It was really hard to make it all private without making it to where I had to send you guys a link to literally every single video I post. So right now the videos individually are public, but the playlist that I sent the link out to last week, that's private. So I'm just banking on nobody stumbling across these through some kind of a bizarre search. So we'll see. I may have to change things as they come. YouTube wasn't as helpful as I thought they'd be, but at least it makes it to where we have unlimited space now. So I will stop there and go work on assigning homework and helping Matthew because he's into something now. So I will see you on Thursday.